Hello everybody, welcome to this new Pix4D webinar. My name is Oliver Kung, I'm one of the co-founders of Pix4D, and today's topic is indoor mapping. Here we are. Just as we get very often this question, this webinar is recorded and will be available on our YouTube channel just a few days after right now, so you can watch it over. The support team is just a few in the other room next to me. So if you have any question during the webinar, you can always ask a few questions in the question box down there. And the support team will answer you live during the webinar. And I will also pick up a few of the most interesting questions and answer them either during the talk or also at the end in a little Q&A session. All right, so with that said, let's start this topic. It sounds like we have a little bit of technical issue, so let me check if first we can get everybody to see the screen and hear the recording and the visuals. So thank you, everybody. Let's restart this session. So today's topic is indoor mapping, and there's plenty to say about it. And I'll start by showing two data sets to illustrate a bit more what type of indoor mapping are achievable using cameras and Pix4D Mapper. So let's start maybe with a smaller one, this one. Okay. So this is the office, our actually sales and marketing office right next to me, which is reconstructed using GoPro imagery. And there you can see the point cloud generated from the GoPro images. From the GoPro images, right there. That would be the reconstruction of the office. So that's a small data set that was done in a very, very complicated environment, and we'll go back in the current webinar, why is it a complicated environment and what can we do to improve that. And then another data set that I'll use during this session to explain a bit up to what kind of things can we do. So that's another data set. This is the Chillon Castle data set. So this is 2,000 images taken with a camera, with the Sony 7R camera. And that's more than 2,000 images taken sequentially and processed together, doing multiple rooms at different level of the Chillon Castle, all processed together in Pix4D Mapper. Okay, so that was a bit a taste of what's possible from a small room till many, many different rooms connected together on different levels. Okay, so first I'll start by talking a bit about the cameras. What are the cameras that we recommend and that allow you to achieve such results? And as of very often, things start with the camera. So here I have on my desk 3 different cameras that we usually recommend for doing indoor mapping. So this is the GoPro Hero 4. Then This is the Sony 7R with a fisheye lens, as you can see in the front. And there we also have the Canon 5D, as you can see, also using a fisheye lens. So why fisheye lens? Well, normally you would not use fisheye lens. In most of the cases, your camera are equipped with normal lenses. And it makes sense because that's where you have the less amount of distortion and you have the actually higher centimeters per pixels. So indeed, and this is true, normal lens, so I don't know, anything from 22 to 50 millimeters, is more accurate than fisheye lens. This is for sure. However, and that's the big problem, achieving correct overlap when you're very close to objects is very hard with a normal lens. And not only achieving the correct overlap, but also the focus, the field of view, everything when you go closer to objects becomes much, much harder. On the other hand, the fisheye lens, if you do all the experiments that I'll detail a bit more in the next slides, at the same distance, you lose maybe 1 or 2 centimeters of accuracy if you were at the same distance than a normal perspective lens. However, achieving extremely high overlap, which is required for doing mapping, for combining the images together, is incredibly much more easier. And that's what I'm going to show also in the data sets that we've acquired there. And okay, you just lost a little bit of accuracy because of using a fisheye lens and not a perspective lens. However, you can get back the accuracy by just going a bit closer to the object. And you don't have to worry too much about the overlap between the images because the fisheye gives you almost all the time perfect overlap. And maybe let's start by illustrating this a bit better. I just took there the camera. I took a normal camera on the left, and on the right, I took a pictures with my GoPro Hero 4 using the wide setting. Well, you have a bit more resolution in the middle of the picture using my normal camera. But standing exactly at the same distance by taking these 2 different pictures, with the fisheye camera, you get a huge more wider area in your pictures. And this helps a lot because the borders of your image, they have a bit less accuracy, but they will be taken in account to help aligning, to help calibrating all the images with respect to each other, to make sure that everything fits in one single model. And the center of the camera for a fisheye, it has higher resolution, and this part is actually the part that's going to be used for doing the matching, the dense matching, and producing more dense points. So that explains a little bit the reasons why you're not losing that much accuracy when using a fisheye, even though there's a lot of distortion. And also the other good news is that Pix4D Mapper has included in it a full definition of how a fisheye lens is doing this type of distortion that makes lines, straight lines, becoming more curves. And thanks to that, these curves do not make the reconstruction worse. Actually, they make the reconstruction, they don't have any impact on lowering the quality. Since we have the model of how these curves are formed, we are able to correct for them and to take them perfectly nicely for doing the processing. And if you have used Pix4D Mapper before, you know that there is multiple steps in the processing. In the first processing step, it's all about image calibration. It's the step which will transform your images into well-aligned images and which is going to allow point cloud densification or mesh or auto pictures to be generated. And one of the main aspects of image calibration is that it requires a very high overlap. And as I've shown before, this high overlap is extremely hard to get for close-range objects with normal perspective camera, but it's incredibly actually easy to get the same overlap, to get in very, very high overlap using a fisheye lens. However, what's also needed is to have many features in the image that are easy to identify and that are spread to the whole well spread and well distributed across each image. This can be improved if you add manual tie points, and there I will show as a tip how to improve the indoor mapping results is by, if the issue comes from the calibration, there you can improve it by adding manual tie points. Once the images are calibrated and the images are well aligned, then the software is performing point cloud densification. So the point cloud densification has many different requirements than from the image calibration. And there the benefits of the fisheye is less important, but since it was used, you needed to have the calibration to go to the densification, then actually it was really, you needed it before. But what's more about it is like the densification is performed locally. And as it's a local optimization, it depends a lot on the visual property of each surface. And as we will see a bit later in this presentation, for indoor mapping, you are faced with many difficult situations because the surfaces are not all good for doing photogrammetry. However, the good news is that you don't need all the time to perform point cloud densification. You can also do manual feature extraction by using the ray cloud and by extracting points. And in that case, you again are in a very high accurate, which doesn't depend on the texture behind it. Finally, and that's a feature of Pix4D Mapper 1.3 that's going to be released in a few weeks, is the possibility to generate mesh. And this mesh, however, they depends on the quality of the point cloud. So for indoor mapping, depending on what type of surfaces you're trying to map, you will get extremely good results, or you may get also lower quality results, but this is good to know in advance what to expect from which type of surfaces. Another thing I'd like to touch first is also the question about a few tips that really make huge differences into getting good results for indoor mapping and bad results. So the first tip was to use fisheye camera. That's the best of all the tips. The second tip is in indoor mapping, most of the time you will have very low light conditions compared to outdoor or UAV mapping. And low light conditions means that the pictures you'll get will be much more subject to have blur, motion blur, or to have noise because the ISO has been a lot increased. So there, the advice number one when doing indoor mapping, taking pictures indoor, is really using a tripod and or a very well stabilized camera. So the less blur, motion blur there is in the image, the better the reconstruction will be. And when you take pictures indoor, your pictures will be much more sensitive to this type of noise. For example, we did the reconstruction of the room nearby, both by night and by day. By day, since we have a lot of windows, we got a lot of sunlight going in the office, and that helped a lot to get better images, even without needing to stabilize too much images. When we did it by night, then we really had to put the cameras on a tripod to make sure that we had enough image quality in each image. And for example, the dataset as shown just before in the castle, these 2,000 images were taken all using a tripod. And then between all the cameras I just shown there, you indeed get much better quality if you're using a larger sensors, such as the one in the Sony and in the Canon versus the one in the GoPro. But the GoPro is kind of handy, and it's easy to get in your pocket and to carry around to take pictures. And you get already pretty good results with the GoPro, and by far from every action camera, that's the one we recommend. On the fisheye specification, we did many different tests with different fisheye, and to try to find what is the best ratio between how much view angle and how much, what's the optimal view angle versus sensors versus quality and ease of use. And really one of the model that we got very good results with is the Sony Alpha 7R, using together a Sony fisheye lens, which is a 2.8 to 16 millimeter fisheye camera lens. Okay, that was a lot about the camera. Now about the environment. So these are the two data sets I've shown before. You have the office environment and you have the castle environment. The castle is going to give much better results than the office one, and this for one main reasons. The office dataset has a lot of shiny, transparent, and uniform surfaces. And all this type of environment of surfaces are extremely complicated to generate automatically very dense point clouds from them. So let's check it out. In this dataset, so this was taken with the GoPro by daytime in the office. You can see that there are many places which are not reconstructed in 3D, where there's no points that's been generated. So let's look a bit more in detail which are these areas. This would be one. So if you look in the ray cloud, what type of images is that? Well, this is a window, and it's a transparent reflective window. And this type of material, as opposite, for example, as a laser scanner, cannot be well reconstructed in 3D in the point densification. So this area will have very little points, and the points they have are very likely to be very noisy, because the surface is not consistent. If you look at different angles, everything will, because of the shiny of the reflection, things will look different. Another place which is a bit more complicated is under the desk. So under the desk there, let's look at what type of imagery we have there. So there it's more a matter of dynamic range. So the GoPro was not able to catch, was adjusting for the daylight outside, and then the image was becoming too dark under the desk. So if we wanted to have also 3D point computed there, we would have to move the camera below the desk and take pictures also below the desk, so it wouldn't adjust for the lighting of the windows. Here we have this door, and actually this is the room I'm sitting in right now. So you can see the contour of the door, but there in the middle there is absolutely no points. If you click on it and you look at what is the texture at this area, it's indeed perfectly white, uniform, and there is no information that can be matched across images to find out what surface should go there, how is there 3D point going there. As soon as there is a bit of information like this door handle, then this gets reconstructed. And even worse, so this was a white uniform area, and there on top, it's not even white, but it's also reflective. As you can see from the pictures, you can see the reflection that's changing from images to image. And indeed, the images are not consistent between each other. And this type of surfaces are extremely complicated to properly reconstruct in 3D. And as you can see, there's even, because it's a very difficult area, there's also a lot of noise, which makes the whole thing not very accurate. However, if you, I didn't load it first. So this is the same, this is a glass window. This is a very white uniform surface. On the back of the office, we have now put some images. So, whoops, there it is. So there you have the back of the office was very well reconstructed because we had some texture, we had some drawings attached to the wall. Now, if you go also, okay, maybe I'll continue from there. So shiny surfaces, like also the table, if you looked in the data set I just showed, the tables are extremely shiny in our office because they have some coating on them, and the shininess makes also them very difficult to reconstruct. Even worse, if you use artificial light like the lamps and not the sunlight from outdoor, you're going to even make the shiny surface even more shiny, and this makes it even more complicated. So to avoid as much shininess, if it's possible, then you should also try to have a source of light which is not coming from one single lamp, but more distributed, such as windows with natural sunlight. These are things you cannot really change. I mean, the environment, if you have a project which is fully made out of glass, the office that we have there is probably one of the most complicated environments you could do a 3D mapping in it. But you can already get some things in it. Now about the image capture. Using this fisheye camera as just shown there, a very good practice is to take a picture every 50 centimeter to 1 meter. So you would move in the room, and every 50 centimeter or every 1 meter, so which is basically every step that you're taking, you can start shooting a picture. Even better if it's on a tripod. And most of the time, you will be at between 1 to 10 meters away from the objects that you try to map. For fisheye camera, this is a bit the optimal, to be between 1 to 10 meters from the environment, from any type of surface which is around you. Something to make sure is not to take pictures too close from each other. So if I take a picture here and I move the camera of 2 centimeters only and then take another picture, this is not going to help, and potentially it's even going to make the results worse. This is all because of the one of the requirements in photogrammetry, which is about baseline. The more the cameras are far away from each other, the better the quality of the 3D reconstruction. So to avoid having too short baseline at certain areas, we really recommend not to take pictures a few centimeters away, but always to move from at least, let's say, 20 centimeters, and ideally every 50 centimeters to 1 meter. Now, the results will be better if you are very close to the object you try to map than if you're far away, of course. So if we go back to this office example, what you can see is that the cameras, let's remove the point cloud. So every shot of the camera was taken with a distance between 50 centimeters and about 1 meter. In that case, what we did is we started from here and we took a picture looking a bit from the sides of, in this range, we take a picture, then we move from 1 meter, we take another picture, then there, and then we started going this direction. We also went inside of the alley to make sure that we have more details about the tables and the offices. We came back, went further there, and also took a bit more details, a bit more pictures around this specific table to have more details on the books that we have right there. So basically, if you are lacking details in any part of your project, the best way to solve it is to go closer when you start shooting your images, to shoot them much closer when you need more details from a certain part of the project. About the processing, when you start putting the images in the software, as you don't have a GPS, as you are indoor, the software will not know which images to correspond to which place. And you should expect slower processing when you have no GPS information, so no positioning information, than if you had. So as you're indoor, you don't have the choice. You can use the software without any indication of position, but the processing will likely be slower. In addition, the software assumes that the images were taken in temporal order, which means that when you start taking your pictures, all right, it's trying to match with more preference images that are close in time. However, if you do a big loop and you come back to the first area, the software will also be smart enough to detect that there was a loop and will be able to match images even they were not exactly taken at the same time, since you were at the beginning of the project until the end of the project. However, something we really recommend to avoid is to jump from one place in the area to the other and to take randomly images. This potentially could also work because software is smart enough to detect that, but you are not helping the software. You're actually making its life much harder. So if you can try to avoid doing jumps, the processing is going to be potentially a bit faster and also more reliable. There's also something you can do is add manual type points to increase the quality of the model. So if you have areas which are empty or pretty noisy in the automatic type point, so let's visualize that. Okay, so you visualize your type points there, and one area like maybe this one doesn't have much type points, but there's many images. Probably it's because there's a mismatch between the images and there's something wrong during the calibration. So one thing to help improve a lot this fact is by going inside of the project and to add a manual type point by clicking on this button, finding an area which is easy to match. For example, the corner of this leaflet. Identify it in another image. And as you can see, the reprojection of the green dot is not perfect, aligned in every images. This is a very good indication that there is indeed a little bit of mismatch in the calibration, and by clicking a little bit in the images, you can really improve a lot the quality of the reconstruction and add a lot more points than when you do densification. So in that case, I will need to click correctly on the corner there, here, and on as many images as needed, as long as the green cross is not aligned for every project. Once it's done, you click Apply. You may repeat this step for a few additional areas in the project. So all the projects which maybe lack a little bit of points or which are a bit too noisy, you can find the tie point, improve it locally there. Okay, let's, for example, this key. Okay, this one was already pretty good, so it didn't need much improvement. Let's say that for a project like that, you could add something like five checkpoints, and then you would click on this button there, Reoptimize, which will reprocess the project with taking in account the click that you just did, and there's a very good chance that the whole project will be more precise and will deliver a better point cloud after doing that. Another thing is very often, as you don't have GCP or GPS as you don't have GPS to orient and scale in the project, once you did the processing with your images, it may be very likely to be in any direction. It could be upside down, it could be, and we don't know the scale of the objects. So you would need to orient and scale the objects. And one way to do it in Pix4D Mapper is to use GCP to do so. So for example, for this project, if I wanted to give the proper scale and orientation to this project, this is how I would do it. You would first go in the GCP manager, and you would set the coordinate system as arbitrary and either select meter or feet. Let's pretend I selected meter. Okay, then you find an object which you can easily identify in your project. Let's say let's use the table there, and you would draw a polyline going from the bottom to the top of this drawer. Okay, you would then fit it nicely such as it fits on the images of this drawer. Apply. And there you have two tie points. You have the bottom tie point and you have the top tie points. These are the two tie points which have been just created there. On the bottom tie point, you would actually change it to be not a manual tie point, but a 3D ground control point. And you would set it as coordinate 0, 0, 0 and click on Apply. Then on the one which is on the top of my of this place, I would also switch it to being a 3D GCP and change it from XYZ 0, 0, 0 to 0, 0, and I would put here a value which I know in that case I measured it just before, which is exactly 1 meter. Now I've set these two coordinates. If I click Reoptimize, these two coordinates will be scaling the whole project. And in addition, as I set it as being the Z from 0 to 1 in Z, it's going to align my project perfectly aligned to this, that this line is exactly aligned to the Z coordinate of my system. So after processing that, the scale of any object in my project will be correct, as well as the orientation of the project will also be adequate. Now let's talk a little bit about accuracy, as it's quite related to that. So to talk about accuracy, we will have to split between two settings. The first one is when you have a perfect surface. A perfect surface is one which is exactly not like the one we have in our office. So it's not shiny, it's not transparent, and it's not reflective. So, for example, such a surface would be brick and stone wall. If you had a wall made out of brick and stone, you would see all the little, it would have a lot of texture on it, and this texture would be able to do a very nice point cloud densification and reconstruction. So we made actually a study, and we are publishing this paper soon in a scientific publication, where we compared a little bit the accuracy between the GoPro, the Sony camera, the Canon, as well as perspective camera. And we compared this with respect to a laser scanner. And what are we talking about then? So just the summary is at around 15-meter distance. So if you take the pictures 15 meters away from the object, you can achieve up to 4 centimeter accuracy of deviation with respect to the laser scanner. In that case, this is really when you use the Sony with this particular fisheye lens, which have a very nice ratio, which provides really very high accuracy. With the GoPro 3 that we used for this experiment, indeed the accuracy is not as good. You achieve more something like 7 centimeter. However, the good news is if we would have gone not at 15 meter, but more like 10 meter or 5 meter, then the accuracy could have gone again below 1 centimeter of error. So it really depends on which distance you are to the object, but on a reasonable distance, you already get extremely high accuracy in terms of for this whole structure. Now, when you have more complicated environments, like the one we have in our office there, the goal is that you wouldn't use point cloud. The best thing maybe is not to use point cloud densification and to use more the manual feature extraction that we have inside of the ray cloud. And maybe I'm just going to show what I mean by that. So let's display again the point cloud. There are several things you could do from such a data set. One of the things you could do is look at it from above, put it in auto view, and that's another new feature of Pix4D Mapper 1.3, which is the possibility to draw bounding boxes. So with this tool, you can basically remove the roof, the ceiling, and the bottom of the project. And now you have all the walls on which you can start annotating surfaces and doing the measurements of the full geometry of your room and drawing simplified CAD models from it. If you needed to pick one single point of this dataset to get something even more accurate, you always have the option to go back using the ray cloud and the nice tools that we have there. So using the ray cloud, you can really measure extremely accurately what would be, for example, the distance between the two sides of this monitor screen. And you would do that by starting in the point cloud. And as soon as you're there, by adjusting in the ray cloud view up to the pixel the size of the screen. And in that case, if you look at how far we were from the screen when we took the pictures, we were pretty close. So let's show the camera. We were something like 2 meters away from the screen. And at that distance, when you measure really the distance, and you did before the trick that I showed about the scale, and you then compare the distance that you got in this way and by measuring with the tape, you are under 1 centimeter of accuracy. You are more in the millimeter range of accuracy by extracting features and measuring distance between extracted features. Another thing you can do, and that's also using the (1.3) new features, is displaying, maybe this time's work. Okay. You can also fill in the surface by producing a 3D mesh, and that would be the 3D mesh that I just computed for this data set. But this is much more for visualization purpose than for real measurement. So in that, there we are able to interpolate flat surfaces when we don't have any data. That's why you have the door which started to appear again. But this is extremely complicated, especially for this office. Now maybe I'll show a bit more back to this very, very impressive data set. So how were the pictures taken in this particular data set? So you can see it goes on several layers and so on. So we actually started from here, and we started taking the pictures by walking using the, whoops, where's the model there? Using the tripod and taking your pictures every 50 centimeters. So let's follow the track. At the entrance of doors, as it's much more challenging than normal corridors, there it's really recommended to take a bit more pictures. So not every 50 centimeters, but more like every 20 centimeters, like it's done right there when we are entering a new room, because all the environment changes a lot, even with a fisheye camera. So once in a room, it was a bit more challenging room because there was a lot of furniture and posters inside of it. So instead of being able to just go one pass in the room, what we did there is that we walked around the room by walking, taking the pictures mostly looking at the walls first, then going inside back in the room, looking more straight forward, another pass where we looked more straightforward, and the last one where we looked again more at the walls to capture the whole scene. And then repeating that for all the different places in the castle. So this was processed as one single project, and on the first processing, it managed to make all the reconstruction of the images, but indeed there was a little bit of drift between the beginning of the whole project and the going back to the same place again, because every image added a little bit of error. But what was wonderful is that for such a long project of 2,000 images, at the end the error was only about 1 or 2 meters between the beginning and the end. And by adding a few manual type points, just as I showed before, you are able, after adding these few type points and clicking on reoptimize, the software was able to actually understand that the beginning and the end were aligned. And by aligning everything went back into one single giant loop. And the relative accuracy of this whole project is extremely high. So this is just the calibration points, so that's not the densified points. Once you densify and you make a 3D mesh out of this project, which again is going to be available in Pix4D Mapper 1.3, which is going to be out in a few weeks, then that's the type of meshing results which you can achieve. And the reason it looks so much better than the one in the office is because the environment, because it's mostly stones and bricks, the environment looks indeed much better. But this is much more on the visual side than actually from the accuracy point of view. Okay, there I talked a lot, and now I'm going to check more the questions and have a live discussion on the questions that were asked during the webinar. And if you have any question about what I presented now, please feel free to put the questions in the software, and I'll be answering live to the questions. So, can the accuracy with the GoPro increase if you use control points? Indeed. By adding, let's say, control points, there are two types of control points. There's manual type points, and there's also ground control points. The manual type points are going definitely to increase the accuracy within the project. And they don't need to be ground control points. They don't need to have a physical coordinate to them. So even if you have manual type points, it's going already to increase a lot the quality of the project. If I was to import the raw images into Photoshop before importing into Pix4D and adjust the lighting, would that help with matches? For some projects, it definitely would, but you have to be careful about when you are changing the raw images in Photoshop, not to do anything which is harmful to the geometry of the images. And by that I mean you should not try to correct for the fisheye effect or for the perspective effect in Photoshop. You should just limit yourself to doing the lighting. Another thing to make sure in Photoshop is that very often it doesn't preserve in the metadata of the image everything which is about the camera, the picture, the camera model, which lens it was used, and these are all information that Pix4D usually is reading to make the whole processing as smooth as possible. Is it required prefer to shoot in RAW in JPEG is acceptable? JPEG is perfectly acceptable. You're not going to gain a lot of improvement by RAW imagery versus JPEG. And usually it's really not worth the trouble of the additional space it takes. However, in some cases, if you are not adjusting correctly for the lighting, for example, you are outside and you have a lot of light, and then you go inside and everything is is and everything is very dark, the big change in lighting, maybe if you had taken in RAW, you could save the day by modifying each RAW images and take a bit more light and adjusting a bit more the lights for each of them. So in that case, the RAW could save a little bit the day, but otherwise, I would keep it in JPEG. It's perfectly reasonable. Should we expect the Pix4D map, the new version of Pix4D Mapper soon? Yes, it's going to come very soon. Both the application for DJI for DJI Copter on the phone, as well as the new version of the desktop Pix4D Mapper, everything's going to come up in January 2015. Would a handheld gimbal help? It would. The issue is not that the pictures are not correctly oriented. It doesn't help. It doesn't help at all. I mean, it doesn't make any change to reconstruction if you hold your GoPro down a bit down like that, or if a bit like that. What is important is that you don't have any motion blur during the processing. So the goal there is really that your images are not suffering from motion blur while taking pictures. And for that, usually you don't have any other choice than using a tripod, or to be very careful when you do it by hand. Can you calibrate a fisheye model? That's a very nice question. So yes, it is possible from the software to calibrate a new fisheye model which we don't have. And for that, you really need a very, very nice data set, and to start by already putting in the focal length of your fisheye. If you have issue with calibrating a new fisheye data set, then we really encourage you to send the data set and the specification of the camera to the support team, and there we have our engineers which will help you to make sure that your specific fisheye gets calibrated. What problems does indoor 3D mapping answers? That's indeed true. And maybe it's also to the other application of what are the applications of 3D indoor mapping? Well, there are many of them. One of them is trying to find again the dimension of a room. Instead of going to measure every corner of the room and every distances, this is basically allowing you to be able to draw the plan of a house without having the plans of the house, as basically as shown when you reconstruct the whole point cloud, and then you get the top view or the side view, and then you can start doing the CAD drawing of it. It's also helpful, for example, for forensic in police, in crime investigation for indoor, when you need to be able to measure what the distance between different evidence in the scene. For architects, for construction sites, to keep a trace of what was in the scene and at which distance were all the different objects. But I'm sure that this opens a whole new field, and we'll find many different industry that will need and use all of that. So let me know of other questions. Okay, should one apply lens correction to the images before inputting to Pix4D, or does it correct itself? It corrects itself. And if you do it before, you are actually lowering the quality of your images, and thus you're also lowering the quality of your whole reconstruction. So you should, as much as possible, not modify the images from the camera, because Pix4D Mapper will take care of that. And as actually, it's not only taking care of that, it's taking advantage of all this of the deformation that were done because of the fisheye. So same for the GoPro. There are possibilities to have less wide settings when taking the pictures with the GoPro. Well, actually, every time you do that, you are lowering the quality of your processing and of your results. So always take with the widest angle as possible. How about using a drone with the camera? Well, of course, you can definitely use a drone for doing indoor mapping with the DJI, but then you more have an issue about flying the drone indoor, which is more a challenge right now than actually doing the 3D reconstruction. How do you handle the high ceiling in modeling a church interior? Now, that's a very good question. Let's, for example, check this data set over there. And that gives you a bit of understanding of also what's happening. If you see in this data set of the Chillon Castle, this is the main tower of the castle. And you have quite a lot of points that were reconstructed on the top of the tower. Well, where does the picture come from? The pictures come only from the one that were done at the ground, something like 30 meters below. And in the picture, you can see that there is the top of the tower. And the top of the tower was reconstructed despite the fact that we are something like 40-meter distance to this top of tower. So of course, the quality of the points, the quality of the accuracy there is not as good as the one which are of a few meters of distance. However, you will still be able to quite nicely be able to map high ceilings at a high distance. And then if you need more accuracy on the ceiling part, then there's no other choice than going closer to the ceiling. And this either using, well, a drone, a UAV, or by taking a ladder and finding more manual way to get the camera closer, or taking a stick and getting the camera closer to the ceiling of the object. But the fisheye is really what makes the possibility to take the images in a very, very nice and easy way without having to think too much how the images are taken. Okay, how long did it take to photograph your office? So to do the small reconstruction of the office, it took about 5 minutes to take the 80 pictures, and then half an hour to process the data set on the computer. For the whole Chillon data, for the whole interiors of all the different rooms that you can see in this model, there it took more like 3 hours to take all the pictures of all the different rooms. And this, in that set, it was really using a tripod. So put the tripod down, take a pictures, move the tripod, take another pictures. But for 2,000 images, it took about 3 hours of work to do this thing. However, to reprocess, there was more like in something like 10 hours of processing on a very good computer needed, because it's a lot of data there. Can we use different camera for projects? Yes, it's perfectly possible to use multiple cameras in a single project. You don't need to stick to a single one. So for Chillon, for example, this is only a subpart of the project. We did this big round with one camera, but then we did the drone reconstruction of the outside of the building using a phantom vision, also using a SenseFly EB, and we merge all of them in one single project. But this is not the one that I have there. If you check the previous webinar of 2 months ago, there we are showing how to merge together a project done with a drone on the outside of an office, and then using a GoPro doing the inside mapping, how to merge these two data sets together to get one full reconstruction of both the indoor and the outdoor. Let's check further. How do we capture accurately the center of a big room like a theater? Then I would choose the workflow that was chosen to, for example, this room. This is quite a pretty large room. And if you look at what was the path that which we took to map this room, is we actually did a big round very close to the walls to get really the nice exterior of the walls. And then we did another circle there in the middle where we were very closer to the objects that were in the middle of that room. But however, between the circles, we didn't do a big jump. So every pictures are very close to another one at about 50 centimeters. So you never have a break between the different loops that we did to do this project. So if you had to do a very big like theater, I would go one circle very close to the walls to make sure that you capture as much details from the walls as possible. And then I would also make a few paths more centered around, for example, the seats or whatever which is inside to capture also the details, more details in the inside there. All right. So with that, I answered already most of the questions that were asked. There's still a few additional questions, but the support team will definitely answer you by even when I stop talking, so you can stay there. So support is catching up with the questions, answering you individually to everybody. Thank you very, very much for watching this webinar. I hope you enjoyed and you learned more about indoor mapping. If you have any additional questions, feel free to send a mail to support@pix4d.com. Thank you very much again, and I hope you have a very great day and very good Christmas and end of year holidays. Thank you very much.